Hello viewers, today we'll look at the power set. That's what we'll look at. So we just have two questions for today. So we have question number one, which is saying state the cardinality and write down the power set of each of the following. State the cardinality and write down the power set of each of the following. So this is our question number one. So this is our question number one, part one. So we have set A, which is we have 1, 3, 5. These are the elements for set A. So the first question is asking us to state the cardinality. So C is equal to, so cardinality, we define the cardinality as the number of elements that you have in a given set. So cardinality is just the number of elements in a given set. So here we are counting the number of elements that we have in our given set, and here you can see that you have 1, 2, 3. So we can see that here the cardinality will be equal to 3. Then after stating the cardinality, we have to write down the power set of A. So I'm going to say the power set of A, it will be equal to what? You always start with an empty set as one of an element of a power set. Then we have a 1. Then you move to what? 1. You move to a 3. Then you move to a 5. So once you are done, now you start with 1, 3. Then you move to 1, 5. Then you move to 3, 5. Then you always include the set itself. That's what you do. So the set itself, you have 1, 3, and what? 5. So that one becomes our power set. So if you count the number of elements that we have, you have 1, 2, 3, 4, 5, 6, 7, 8. So if you want to confirm the number of elements that you are going to have in your power set, you say 2 to the power c. So 2, then c is the cardinality, which is 3. So 2 to the power 3, that's an 8. So this will confirm to say you are going to have 8 what? Elements in your power set. That's what it means. Then we have our part 2. So for part 2, we have elements. So I have 2, 3 and 3, 7. So this is our set B. So as usual, we have to state the cardinality. So cardinality, it is just the number of elements that we have in a given set. Just the number of elements of a given set. That's what the cardinality is. So we just have to count the number of elements in our set. So you have 1, 2, 3. So we can see that the cardinality here, it is a 3. 1, 2, 3. Then this 3, 7, this is you're going to treat this as one element. So no wonder I was saying this is the third element. So you treat it as one element there. So the cardinality here, it is a 3. Then now the power set now of our B, it will be equal to what now? Always start with an empty set. Then we have a 2. Then we have a 3. Then we have a 3, what? 7. Then we have a 2, 3. Then we have a 2. That is what? 3, what? 7. That's what we have. So now from here now, since we have those so far, so you move to, so you start with an empty set like I said, 2, 3. Then yeah, I say an empty set will start, then followed by 2, followed by 3, then followed by 3, 7 as one element. Then now you start 2, 3, and also at 2, 3, 7. Then you don't close because you are still going. You close here, then because you are still going now because we're at 2, we're at 2, 3, 7. So now we move to 3, what? 3, what? 7. That's what we have. Then now we'll end with a set itself, which is 2, 3, then that is comma 3 comma what a 7, you close and close again. So when you count the number of elements, you should also have 1 2 3 4 5 6 7 8. So if you want to confirm, you say 2 to the power 3, you're going to have 80 elements. So that one becomes the power set. Then we have our last question, which is question number 2. So question number 2 is saying that suppose S is equal to X is such that X is a member of an integer such that you have 2 which is less than X less than or equal to 7. That's what we have here. So how do we answer the questions that follows? So we have our part 1, which is saying express S in roster form. So you are saying express S in roster form. So meaning that we remember roster form is just a listing of number of elements of a given set. That's what roster form is. So roster form is just a listing of the number of elements of a given set. That's what roster form is. So here since we are saying X is such that X is a member of an integer, then you have 2 which is less than or equal to, which is less than X less than or equal to what? A 7. So if you are to list this, you can see that our set S now in roster form will be equal to, so we'll not start at 2 because at 2 it is less, it's not less or equal to, so that 2 won't be part of our element. So we'll start at 3, 4, 5, 6 up to 7 because there's the equal to sign there. So that will be our set S in roster form. Then for part 2, part 2 is asking us to find the cardinality. So the cardinality, if you remember, you're counting the number of elements that you have in your set. So how many elements? 1, 2, 3, 4, 5. So the cardinality here will be a 5. Then part 3 is asking us to say how many subsets does S have? How many subsets does S have? So to know the subset that S will have, we say the subset is equal to what? The subset is equal to 2 to the power what? N. So it will be 2, okay? That is to the power N is 5, okay? The number of elements of cardinality, which is 2. So meaning that this our set S, it will have 32 subsets, which will be the same as the number of elements that you are going to have in your power set. Then the last part is asking us to say how many proper subset does S have. So here we need to know how many proper subset does S have. So to know the proper subset, you're going to say 2 to the power N minus 1. That's the formula we use. So it will be 2. Remember N is what? 5 minus 1, which will be equal to 32 minus 1, which is equal to 31. Or you can say the subset minus 1. So meaning that our subset, meaning that S will have 31 proper subsets. That's what we are going to have.